Well, hi, and welcome to my shop here on a snowy, dark day. Yikes. Fortunately, snow is melting away when it hits the ground, but it's a sign of things to come for sure. One of my later projects today is to put the snow tires on my truck. So, yes, winter comes. We cannot deny it. Now, what about this radio? So yesterday I completed the IF alignment. To me, this is just an initial run through of the alignment process. If I don't get it all right, that's fine. If it doesn't come out, bang on, that's fine too. And that's good because I realized as I started today, just looking over the instructions I'll be following in a little bit, that I didn't actually complete the IF alignment. There's one last step, and the last step is the same as the first step. For some reason, they want you to align the second IF transformer. That's this one up here. This one here. And then align the first, which is normal, and then go back and check the alignment anyway on the second again. So that's where I'm going to start the checking of the alignment, and then we're going to move on to doing the various shortwave bands, and I guess the broadcast band if I get there. And I'm pretty excited about that because this is when the radio will really show itself for what it really is at this point. I do not have B+ on the radio yet, so let's put on the clamp here. Let's give a little volume. Where are you, radio? Don't be... Huh. Don't be dead. Okay, rather than worry about what just didn't happen, I'm going to carry on here. This is an outdoor antenna. Off it comes. And we want to attach this input there. I've got my signal generator running at 460. You should really see it say 459 on here. That's a little better. Put this on a good grounding spot here. Come on, radio, what's happening? Oh, no B+. No B+. That's why. No B+. Let's leave it unhooked for now. Okay, that's why I didn't hear any sound before. Okay, so these tubes have been warming up for 10 minutes or so, maybe. And now we're going to stick with B+. Everything should be set to go. We should hear something come out of this radio. A pop. Well, maybe not. There's no antenna. Yeah, a little bit of noise. So I'm putting it up at 25 milliamps. I'm just aiming for 25 milliamps for consistency. That's yielding B+, a low B+ of about 120 volts or something of that sort. But the radio's operating. Good. Now if I touch this, we hear it. So I will now inject the signal. Don't hear a thing. Okay, don't anybody panic. Could be the level is just too low. Let me turn it up here. Yeah, that's all it was. Down on the volume. The sound quality is good, so I don't think I'm overloading anything. Although we are putting a pretty strong signal into this, into the grid here. Now, question is what happens on this meter? Good. Should I adjust the signal generator slightly? I don't think so. I think I should leave it just exactly where it is. Get my tool here. Watching the meter now. Down, down. Does ever sound grindy in there, eh? So, okay, ready on the bottom. Down, up, and down. This one was slightly different. And we're talking a fraction here. It's not going to make, I don't think it'll make any difference in the long run. Can't get much better than that. Okay, we have now completed the IF alignment. It was just fine as it was. Next stage. Just turn that down so we're not listening to it. So from here, I think we're going to have to look at the instructions again. See what they say. Okay, so on the chart here, so I just did this. Wait a minute. Wait a minute, I didn't do this. I made a mistake. So I move, oh, I see what you do. So you do the second to get it lined up. Then you move your input towards the antenna. And now you have two IF transformers. So you tune the first one, you tune the second one first one second. And then without moving this connection, which is what I just did, I just made a mistake. So we got to go back and do that once again. Get this absolutely right. That's why I don't sweat over first time through the alignment process, because I just know I'm going to make mistakes. You know, so rather than beat myself up about it, I've just accepted that the first time through, crazy stuff is going to happen. So we want to put this back on the other. Let's do that. Let's take this off. Okay, we want to go back here. Hey, I'm a good antenna today. That's the French station coming through. I guess that's where I left the radio tuned. That's a pretty good sign. What does that actually mean? It actually means I'm bypassing the front end of the radio and sticking basically an antenna signal in, and it's coming out okay. That suggests the front end of the radio, the very front end, is not tuned up very well. Once it's tuned up, how exciting is that? Okay, so we're still at 459. Don't hear anything coming out. I hear it now. Now we'll go back. I can actually do all these at this point. Back here. There. Okay, watching the meter again. Probably going to get no difference. Good. Wow. You know that sound? That's what it feels like too. It's just grinding away in there. Okay, bottom one, watching. It's the same point. Good. Okay, now we followed the instructions properly. Pop this off. Pop this off. I just have to grab the body of the capacitor. What if I put my finger on the antenna? It's even better. What's the jumpy? This. Oh man, that's great. Okay. Wow, the next step. Now we're ready to take on the next step here. Now I got it. Next step. Antenna terminals, 400 ohms, 11800, and we're doing three things. We're doing the oscillator, the detector, and the antenna. Okay, so here, max peak, and it's got all these things here. And remember to check that stuff out. That one, the first one, if two peaks obtainable, use the lower inductance. Screw further out. Is there some initial? Yeah, turn the screw all the way out. Check. Yeah, I did. Is there another one? There isn't another one like that, is there? I don't think so. I'm sure it would be on the chart. So I think we're ready to go. 400 ohms, 11800. Okay. Oh. Come on, peanuts. 11. I hear you. 11800. Right there. That's good. Now the signal's being injected into the antenna, which is just right here, with a dummy antenna of 400 ohms. Oh, I used the word dummy antenna. So to some degree I don't need to do this. I mentioned this earlier on another video, or the last video. I do have this box here, which serves the purpose. It's called an antenna simulator. And in here is a simple circuit. You can put this box either direction. It's the same thing either way. Has some capacitors and stuff in there to provide a standard antenna simulation, which is a standard that some radios refer to this exact box. And I've actually built what's in that box before I had that box once because the radio required it. So what should I do? Should I rely on the box and not put a 400 ohm resistor in? If I put a 400 ohm resistor in, am I overdoing it because the box is over there? So what this box looks like to the radio is 200, 300 ohms. And what the box looks like to the signal generator is 50 ohms. How can you flip it back and forth? Well, I think I'm going to go deal with my cat here because he's not going to stop. Hey, Peanut. There he is. How surprising is that? Peanut, my what? He came in this morning, 5 in the morning, got on the bed, woke me up. Hey, you, I'm talking to you. I'm talking sternly to you. Yeah, that's right. You were clawing me, you were poking at me. He pokes my nose with his paw. Yes, you do. Okay. See, this isn't going to end until he gets what he wants. I've spoiled the cat. and he's turned me into his slave. Okay, I have to go be Catman for a while here. I'm hurrying, man. Hold on. Okay, let's get the radio onto the right band here. Wow, it's a long ways that way. Let's go this way. Yeah. That's it there. And I know I've got the right one. The light has come. Oh, that's right. I got the sensation the lights were out of sync. Well, so unlikely. So we'll tune the radio to 11.8 on the dial. Right there. 11.8. And we have the output just laying over here. The signal generator output is a moderate signal. Certainly the radio should hear this. And it's not. If I remember right, this was way off. Oh, some company is arriving here. I guess this is what happens as the winter comes. The cats they get more indoorsy. They want to participate, don't you? Okay, so we didn't hear that. So what I'm going to do is set this back to 11,800. We're going to crank this guy up. Okay, any decent radio, any half decent radio would hear that. Volume's up. See if we can find it. Right, shadow. Right. Does it really be the band switch is turning the wrong light on? Or is the radio not working? Or did I do something wrong here? Let's check this. Let's check I did something wrong. No, I didn't. B plus is, we still have 25 milliamps flowing. A little less, actually. Volume's up. I can hear the radio. Okay, well, you know what? If it's not, there's an easier way. If it's not, so maybe it's the 15 megahertz band. Then it would be around 15.2. And the answer is no on that. Okay, so if it's not that band, then it might be the 9 megahertz band would be around 9.5. This is just an absolutely paralyzing result here. Absolutely. I got a stronger signal at 9.10, weaker one at 9.5. That suggests that, because I have the radio tuned to 9.5, that the 9.5 band is on right now, but the light is on for the 11 megahertz band, and also this band appears to be aligned on the image. Wow. that's a whole pack of crap there all at once. How can this really be? How can it really be that the lights are not correct? So you can move these around on the post up here, but that much? Really? I can't imagine that these lights could be repositioned significantly. So another possibility is, I've just lost my mind at this point, and that's certainly a possibility. And you're not helping any, Shadow. The black cat has crossed my path here. Well, I don't know what to do. Try another band? Well, then let's go back to the 11 megahertz band and find out what the radio is really receiving. I am there. I am. What am I talking about? I'm all spun around. Let's go down to the 9 and see what's really there. How can this really be the case? Now, maybe the light won't come on. The light in my head won't come on. Well, there we go. So I got the 9 light on. There's no question. There's no question which light bulb is on. The question is what band are we on. So now I'm on the 9. I'm feeding it roughly 9. Let's just move this 9 around here a little bit. Just be sure that, yeah, it's not picking it up. So if it's not 9, maybe it's 11. Okay, let's go up to 11. See what happens here. Here, come on over this way. Go watch the numbers. The thrill of it all. It's not very thrilling. Then it would be 6. Change bands. Here it comes. There it goes. Another possibility is there's something really wrong with this radio, like really wrong with it. So we're on, according to the light, we're at 9.5 megacycles. Okay, I'm giving it now a very powerful signal. Right past 9 and not hear a thing on this band. So what is it? It's got to be something, doesn't it? Doesn't have to be something. Did the band switch not quite click in? Okay, turn. So I've got the volume way up now on the radio, and the objective of that is to hear the crackle. Do it by hand. tough switch to move. There's an alignment problem in the switch. So I'm on a band and it's quiet, and as I go to the next band in the middle, the lights don't appear to be right. Yeah, volume's up, Jim. Now that seems okay, but that doesn't. But then hearing this in between could just be baloney, right? It could just be baloney. Another radio, I can't even figure out what band I'm on. Oh my gosh. Holy schmoly. Okay, let's go all the way to AM band. So that's what the radio can sound like, even with a terrible antenna. It's just the signal generator for an antenna. There's no question this is the broadcast band. I know it. The next band. Okay, that's loud and clear. What is it? I hate to say it, that sounds like the broadcast band. There's no lights on. There's no lights on. You already know that. There's no lights on in the shot. Okay, well, I would guess you would just work your way up the bands, not necessarily, but this would be 6.1 megahertz. I got very strong on this line. Let's turn it down. There we are. Okay, no question. Excuse me, Cat. Get this piece of paper here. And I am going to mark the band numbers as I prove them out. So, band 1 was broadcast. Band number 2, in order of the switch, is it's a 49 meter band. Now we're going to try to find out what band number 3 is. So I'm in there. Band number 3 is silent, which is a sign of something bad. Band number 3 turns on the 11 megacycle light. So this is 31 meter band, I think you call that. Call that the 25 meter band. 25 meter band light. So this should be picking up 11 megahertz. Okay, full blast signal. Yeah, 10.4. It picks up, it receives at 10.4 when the radio's dialed in at 11.8. Could be the oscillator is just way out of whack. I would explain why the reception's poor, because when you get the oscillator way out of whack, then the radio operates out of alignment with its front end. So why don't I check this? If this is way out of whack, I should bring it into whack, into some, even though it's not the right order. I didn't expect anything good to come of this the first time through anyway. So which one would that be? So we're on the, once again, we're on the 25 meter band. I'm just going to take a peek at the chart here. So 25 meter band. Do you actually say that? No, that's the 3. Yes, you do. Oscillator L16. Oh, and this is the thing with the 2 peaks and the whole shot. I bet you this is just a really messed up radio. L16. So we have to find L16. And hang on while I look for it. L16. L15. L16. So L16 is on the back apron. Right here. This is 16. And it's cranked all the way out to the chassis practically. Well, we'll turn it now and find out if this is the right one. But nothing happened. Because I'm in the wrong one. Bozo. Can you look at a diagram within 2 seconds you got it wrong. L16. That was dumb. So this one is not in a funny position. It's there we go. Well, come on. This should be causing that signal to vary. So the light is on the 25 meter band. I'm reading this right off the dial, so I can't get it wrong. The 25 meter band. We have the fuse, the socket, and the things. Yes. It's this one. It's this one. This is the 25 meter band. And this is the oscillator, isn't it? L16. L16 was, just 1 second, I'm absolutely sure of what I'm doing, sort of. Oscillator, L16. What is going on in this radio? Well, I'm going to turn another one of these guys, and if one of them's got to have an effect. Watch this meter. So this is having an effect. Not much. Doesn't seem right. Usually when you're turning these adjustments, it's like you can't even hear the difference, right? This is just a small change in volume. You know what? I've got this thing cranked up so high. Maybe that's what's going on here. Yeah. You know what it is? Maybe I'm just fighting with the AVC and I really can't. There. So I got a little noise in here now. By now I've messed the whole radio up. But again, this is why you got to do this once. Make the mistakes and not worry about wrecking your efforts. I don't think that's changing. Oh yeah. You gotta go 20 miles. That's just... That one's changing it, this one's changing it. This one has more effect. But that doesn't guarantee anything. There could be a very important order here. Let's just do this. I look at these coils, I see there's another one back here. Very fine wire, heavy wire. This is the one that is supposedly the oscillator. Look at it, doesn't do a thing. This one. Uh-oh. Uh-oh. Maybe this is a good thing. So obviously I've just knocked the wind out of this radio. Let's go find the wind. solder joint up here. I think that's what it is. Cold solder joint. This is probably what I was chasing before, I don't know. Okay, found it now. That's right on the ground, but I think I'm gonna kill the power here. I'm gonna solder that. Okay, that might have been the 3-day misery tour I was on because of that thing right there. I did the whipsaw thing before, but I guess I just never hit the mark. Okay. You know, like these connections are hard to make because they're right on the chassis. I keep them off the chassis on the little bit of wire that's left sticking out, so I don't solder right up on the chassis. But look, there's a big pile of solder and a pile of connections, and I just never got this guy out enough, I guess. Where's the solder? Oh, solder, right. Solder's in my office. We'll use this here. I'm just mainly heating this up anyway and remelting it. Okay, a little bit of B+. That appears to be working a lot better. That appears to be working a lot better. Okay, now did that change everything? So we're on attuned to 11.8, but we're still seeing 10.4 here, which is way off. Now, what about these crazy coils? Well, let's see, this one. Well, okay, so we have lots of heavy wire, a little less heavy wire, minimal heavy wire, fine wire, a little less fine wire. These are in order. Can we not put these in order? Can we not say the one with the finest wire it doesn't even have a tuning slug, so there's only 4 of them. So wouldn't this be like a high frequency, low frequency, or vice versa? What's it show on the chart here? Just one second. Let me just look and see what it says. So the way this works is this one. I'll make sure we don't have this upside down here. No. This guy farthest from the fuse. Yeah. Farthest. This is the broadcast. Broadcast oscillator, and then this one, wait a minute, farthest away. This is the 31 meter band. We're listening to 25 meter band though. The 25 meter band has to be lower. Has to be this one. And the 19 meter band, 15 megahertz is this one. But these are the ones that seem effective. What the heck is going on? Yeah, that's a question I seem to ask an awful lot. Well, it sort of seems like this is the 11 megahertz band way out of tuning. Way out. The slug is cranked in much further than the rest. There was something about the peak for this. Let's see if this is really the problem. Let me just reread what it said about that. So we're going to try to do the oscillator L16 for a maximum peak. If two peaks obtainable, use lower inductance setting. Screw further out. But the screw is not very far out on this. It's in. Okay, maybe it's on the wrong peak. Let's just crank this baby a long ways. It's another case of this thing being screwed down all the way. Just nothing happened, is there? As much as you're helping, Shadows. This has just made zero difference. So what is it making a difference to? Well, you're lucky this isn't an electric thing here. Not supposed to crunch on that. Oh, look at that. Sharp little teeth. Well, how could I have the diagram wrong? Let me put the diagram on the screen here. So this is the back apron. We're looking at the top, so you would fold this downwards for its normal position. On the left is are the connections for the phono, and on the right are the fuses. So on the right, towards the top, I mean, these are shaped, like there's a U shape here. I can't get this too confused. Can even see that this hole is higher than that hole. I mean, there's no way I'm confused about this. And so clearly we're on the 25 meter band. Yes. 11 megahertz. It says 25 right there. L16 right there. 11,800 kilocycles right there. And that is definitely the one that I turned out a long ways. Well, it comes back to the idea that we're not on the band we think we're on. The lights are messed up. Somebody managed to sort of semi-align this thing or force it into some kind of operating condition with the wrong bands picking up stuff. I can't imagine that. We need to prove the band lights, the band switch. Can you hear it in my voice? This is just crazy stuff. Okay, let's just look at that band switch a little closer. You know how many times I've gotten into situations doing this, hundreds of times, where what I believe I'm seeing, I'm saying to myself, this just can't be the case. I have had one case of a switch out of alignment in my CB, my Heathkit old CB radio, where I had taken apart a band switch like this. And see that this is the drive shaft here. I pulled that all the way out so I could see something, do something. I don't know. When I put it back in, the wafer had rotated 180 degrees on the switch. I slipped this back in, and then this switch was 180 degrees out from the other switches on this other radio. And I went berserk trying to find that, because you just don't expect it. It's just not on the list. So let's make sure the switch is turning. The wafers are moving. That's one thing we can do here. Let me just turn it down a little bit. Okay, now. No question, the wafers. I'm looking at first at the back wafer here. I mean, how can these not move? And then I'm looking at this one here. Could be these switches are so filthy dirty, they're just not doing the trick at all. That's, you know, that happens, but it's, in my experience, it's actually not often these switches are that bad. The switch is definitely moving. So it's not like anything's been ripped apart. Somebody's driven this switch past its limit and ripped something apart. I'm not even sure you could do that. I mean, these things are pretty rugged stops. I don't know. Okay, hey, time to do some switch cleaning. Might as well do this. I'm going to end up with egg on my face. And look what I have to pick from. Dun, 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 dun. Sorry, I'm trying not to bang my bench top here. Look at that. Let's start with this one. Color. Non-drift color. I spelled color wrong. TV tuner cleaner and lubricant. Oh, this one has some lubricant in it. I looked at these cans wondering what exactly is in this stuff. And in every case, it was the same thing. Pour la TV en couleur. Do not place in hot water. I live in hot water. Maybe one of them I thought didn't actually declare what it was. It could be this one. The other two, it's isopropanol. Isopropanol is a fancy word for alcohol. Just alcohol. This is probably the same thing too. Contact and head cleaner. That's a Radio Shack. This is old stuff. This is from a long time ago. Intertan. And this one will say on it somewhere, a long list of things you can clean with it. It'll say isopropyl down here where first aid treatment, contact eyes, flush thorough, swallow, call physician, or poison control center immediately. Contains isopropyl alcohol and butane or something like that. So there's nothing in here. It's just alcohol. I like alcohol. I like alcohol. Hey, I'm Canadian. Cannabis is on the list too. That's not what I'm talking about though. I like using alcohol because I think it's pretty harmless, pretty safe. It's not fumy. The only thing is it catches fire, and I have set a radio on fire doing this exact thing right here. I'm going to want to put the brake on. Okay, I want to get this tool. I don't want to work the control. And I really shouldn't have the radio on, Jim. That's kind of dumb. I turned it off. Holy smokes! What can happen? You get a little spark in here, because sometimes these contacts are switching B+. You get a little spark, start a fire. And I'm telling you, I had it happen. I have a video of a radio on fire. An old one. Good. Come on, you can do it. Now, there's no other than the radio not working right. I don't have any indications that there's a problem with this switch. Everything I've done has told me it's okay. Just alcohol everywhere. And which one is doing the lights? The switch that's doing the lights is going to have a pile of wires coming to it. So the wires come in here. It's this one right in the front here. There's just no possible way you can get out of sync one step. That can't really happen. Can it? No, what's more likely to happen is the lights have been taken off and put on again wrong. Maybe, I don't have the cabinet to read the order of the band switch, but maybe there's somewhere else in the manual the order of the band switch is declared. So I'm going to look for that. I'm going to look for that because that would end this whole misery here of what is going on. Let me look for that. Well, I still haven't sorted out the band switch. I can't find any reference of absolute certainty as to which band should be on. I still have the vague impression that the lights are out of sorts for the band indicators. So what I've concluded here I have to do is get my SDR radio going and detect the local oscillator on each band setting, and then figure out that local oscillator must indicate it's a certain band. That's the only approach I can come up with. As crazy as this is, I can't go forward without some kind of certainty here. So, I'm going to set up to do that. Okay, so if you think what I'm doing here is crazy, I agree, it's totally crazy. But I really got to get to the bottom of the question of what's going on with these band switches. Now, if I had the cabinet here, I could just look at the front of the cabinet. I don't have the cabinet. There's no references in the manual directly that'll help me do this. So I'm showing you the coil. It's just a clip coiled up a little bit, and it's just sitting on a plastic holder here. That's all. Just my camera crane that I use for the camera sometimes. So it's just holding it near these coils. That should provide plenty of local oscillator signal. First band we're on. Oh, I switched it. Okay, well, we'll start with this band. So you can see the light, and the band is the 25 meter band, and that's 11.8. Wow, where I'm pointing right now, 11.8 megahertz. The radio actually tunes in 10.4. So I want to get this 10.4 out of the way here. I'm just going to turn this way down. Maybe I'd be smarter and even disconnect it from the antenna. So we don't care about that. All we care about is what shows up on the SDR. So yeah, SDR screen. Tell you what I'm going to do here. I'm going to go back to where I started. Here. Now you can see on the SDR as I turn the band switch. Whoops! Oh, I have this all set up nicely here. You can see everything that's going on. Okay, so right now no lights are on. No lights are on. What happened? Did I burn another light out? No, there's three of them. So the light that's on, I'm at one extreme of this control. The band light that's come on is the 6 megahertz band, 49 meter band. The radio's tuned to 6.1. With it tuned to 6.1, the local oscillator, assuming it's above, would be 6.1 plus 460, 6.560. 6.560. So we look on here. 6.560 would be right about in here. What I expect to see is a pretty tall signal where the local oscillator is, but there's really nothing much here. Now what I'll do is I'll tune the radio, and if you watch the SDR, what I'm really doing is I'm varying the local oscillator, so you'd see it move. There's nothing moving. So let's just go over this again. Okay, because I already did this a little bit just before I turned the camera on to make sure everything would work right. Okay, this is the light that's on. Look, you can see the light on my finger. The band, look, you can see it says 6 megahertz. Sorry for the lousy camera work. You can see it's tuned to 6.1, roughly. A little parallax there. 6.1. So 6.1, 460 is 6560. Nothing on the screen at 6560. I'll put the red line here. This is the mark. This shows where the SDR itself is going to is tuned. So I'm going to put it over here 656. So we expect something to show up somewhere around here. And when I tune, it moves. Well, maybe this isn't that band. Maybe this is another band. Maybe if I turn the band control, I will find the band. It'll be the one that pops up a local oscillator on the SDR. This is the craziest thing I've ever done. Okay, here we go. One switch. Nothing happened whatsoever. Okay, another one. Some little things popped up there. Let me tune a bit. Okay, they're on the move. But they're not in the right place and they're way too weak. Another switch. A bunch of stuff is showing up and something very strong way down at 5.6. Now let me tune the radio. This is where things get interesting. There's also a strong one at 6.3. Okay, tuning. So we see things moving. Now I'm tuning up band. The local oscillator should be going up band. I see that powerful red one on the left there at 5.650. I think that's the local oscillator. Look at how powerful it is. So wait a minute. So I'm far away from the 6 megahertz band according to the lights. There's no lights on. So maybe this is the actual 6 megahertz band. And it's aligned way out. Maybe that's what's happened here. I can't imagine. My explanations don't hold water. Okay, so let's go another band forward. Now we're at the end of the row. Now we see a nice clean signal there. Right. Let's just turn this a little bit. So now what's happening is you're seeing that thing move on the SDR, but I'm barely changing the tuning on the radio. So this thing we're seeing on the SDR is moving at way too high a rate to be the local oscillator. Is it an oscillation coming out of the radio? Is it some weird effect of the SDR? I can't answer those questions. So what we're really left with, there's a lot of weird stuff when you use an SDR to do this. So the setting that appears to be the 49 meter band is one back from the end here. That's the end, one back. With the local oscillator adjusted 16 miles out. Now if that's really the local oscillator, that means if I turn the oscillator adjustment here, the trimmer or the slug, then we should see that oscillator move. Just give me a second here. I just want to look back at the manual and make sure So we think we're on, oh my god, I've lost track of what I'm doing. Well, we think we're on the 49 meter band. And the oscillator's way low. 49 meter band, oscillator way low. Meter band 11.9. There is no 49 meter band adjustment here. 49 meter band. There it is. Oh, look at them all. 25, 25, and 25. There's the 3 for the 49 meter band. We're still in the process here of just trying to prove what band I'm on. Oh my god. Okay, so it's right near the capacitor. Near the, so I see which one it is here. Oh yeah, the camera's on. It's this one here. I have to adjust this from the top. All I want to do is adjust this a bit and then watch the SDR and see that it moves. So it's on the other side of the radio. I'm pretty sure you can't do anything up these tubes here. This is what I'm fiddling around with here. I gotta get to it from the other side. And these are the most awkward things to adjust. Now they have locks. It's basically a rod. Now you got to hook the top of this rod through a little eye hole, and then you push this rod up and down in this fitting here, and that's how you change the capacitance. I don't know why there's so many of these in radios. They seem to me to be a really unattractive way of doing it. I'm just sorry I'm in front of the camera. I'm looking for a particular tool, which I'm not finding. I have an ideal tool for this. Son of a gun. Where is it? Yeah. gotta stop and look for a tool. Okay, I think I'm ready here. So I've had to rearrange the radio. I turn it around basically. So I've relocated the pickup point for the SDR you're looking at on the screen. I've got my coil just laying over the top of this tube. This is the oscillator tube. Very strong signal going to be on it. And sure enough, when you look at the SDR, you see a big whopping signal out around 5.675 or something like that. And we'll now tune the radio a little bit and see if that local oscillator doesn't move, or does move. It should move. As awkward as this is becoming, watch. Perfect. It's almost doubtless that that's the local oscillator, and it's in a pretty dumb position. You know, unless this radio has the local oscillators below the target frequency. If that were the case, I think the radio's tuned to 6100. Then you would subtract 460 from 6100 and you would get 58 something, 50. So let's see, well, let's do it this way. The frequency of interest is around, let's say, to make it easy, 5640. You add 5640 and you add 460 to it, you get 6100. Now, it's possible the local oscillator is there because it's wrong, because it's in the wrong place. It's supposed to be above, and somehow somebody got it below. And that would pretty much ruin the sensitivity of this radio, because the rest of the alignment is not going to follow on very well. Is that what happened here? Then I'm making the assumption that we are looking at the not the assumption. We're looking at the local line. What am I supposed to do? Oh, gosh, right. I'm right. Back to what I was going to do. Let's move this slug. So I have this weird tool here, okay, which is pretty useless in most cases, but in this case, here's one here. These adjustments, they have a hole in the top of it, and you can put this pointed part through the hole, and then you got twisting power, and we got muscular lifting power. This is a lock, which is probably locked. That's probably locked. You need a nice tool to come down above and do it, but I got nothing that'll do that. So let's see if I can move this. And I'm going to watch the local oscillator. If I just move it a touch, they all seem to be pulled up pretty high. Okay, so first I'll see if I can rotate it. That'll indicate if it's loose. Oh, it's easily rotated. Okay, now I'm going to move this on the theory that this should cause, I better hang on to the radio here, the local oscillator to move. Okay, so I'm watching the local oscillator. Move. Didn't move, didn't move, did it move? Well, it didn't move much. Okay, so hold on. That's a terrible situation now. Either I just moved the wrong control because I confused myself in the process of doing this, or it's not at all what I think it is. Let's go back to the let's go back here, and how, so I convinced myself, yeah, I did the wrong one. I think I'm moving this one. I'm supposed to move this one. I did the wrong one. Okay, that's good. This is the reason why, again, I don't expect myself to get anything right on the first time through here. The whole thing will be a write-off, but next time through I'll get everything right. Okay, so now we're on to this guy. Oh, look at it. See it jump? I just put my finger on it. A little bit. Okay, we're going to try to move this one. First, rotating it. Oh, look at the movement. Okay, so what this is saying is you are on the 49 meter band. And the local oscillator is in a stupid location, or it's below. I didn't read anywhere in the manual where it says above or below. Wow. Now, I want to know where the band switch is set, and then I want to make a note about it. Swing this guy around further. Can we get him all the way around? I don't think so. This is pulling a little tight here. What am I trying to do? I'm trying to get all the way around to see the band lights. We're not going to get that way. Not going to get there that way. Go this way. Around and around and around we go. Which band lights on? Nobody knows. Okay. So there's no lights on. Yet I know when I'm on the 49 meter band, this light comes on. We can be pretty sure that's the local oscillator there. Again, tuning up band. And let's make it more accurate. You know, see funny things going on in the SDR, those things coming together. You know, that's either a weird thing about the SDR, or it's a weird thing that happens with these superhit radios. I haven't decided what the heck that is. But not to worry about it. Just look at the big one. Forget the little guys running around there. My guess is it's actually an artifact of the radio itself. And I see these things all the time when I do this. And I've never really gotten a full grip on them. So we want to put that local oscillator, let's say, right at 58. Oh, wait, I hit the end of the road there. We'll put it right at 57. 5700. So add 460, we get 6160. The radio is a radio tuned to 6160. 6150, 6160 is right there. So yeah. So either correctly or incorrectly, the local oscillator is running below the target frequency. That's just a little unusual. Now this proves the lights are wrong. We're on this band. I've proven a couple of times the radio is behaving as if it's on this band. Now I'll make the light come on for that band. There. Way over here. We need to look at the possibility that the lights have been moved around incorrectly on here. And you know, it's not unreasonable to think that, because half of them are burned out. So how would you ever know? And somebody can very innocently, without thinking, take all the lights off in order to replace bulbs or something, and then realize after getting them all off, oh my god, I don't know which one goes where. On the other hand, the wires are so short on this, you know, what kind of options do you have for messing it up? That's what I want to take a look at here. Just bear with me a second while I do that. So we're wondering about literally slack in these wires. I think I'm going to have to refocus my camera here. Slack in then their wires. How much slack is there that you can move them around? I mean, these things are usually made to fit, aren't they? Oh, I don't have the, hang on a sec here. Okay, so we're looking at the lights here, and I'm going to look at the black. It's like some of the wires do look a little funny, have a bit of a funny bend in them. Like this bend here. And this one here is just a little odd. Like, why would they put? Wouldn't they make all these wires just exactly the right size? They would look uniform. Wouldn't they look uniform? There's not a lot of play here. Like, for instance, this yellow wire, which is going to the first light, which is the band in question. It's really short. I mean, there's no way you couldn't put this anywhere else. You couldn't really mess these up. you might have these two might be backwards. Maybe this one should be over here and this one should be over here. Well, that would cause these wires to cross. If somebody pulled these off, then they would be inclined to put them back in a pattern. And they'd look at these wires, and these black wires in particular, at least I would, and I would say, okay, well obviously this one has to go here, and this one has to go here, because you can see how the wires are looping. You know what, they really look correct, don't they? So the wires are colored, and there's some color code information on the chassis. And if I study that long enough, I can figure something out. But the problem with colored wires in these radios is the colors they are today aren't necessarily the colors they started out in. And sometimes you can pick at a wire, pick at the insulation a bit, and see the color, especially at the end, you know, where it's cut back. You can kind of poke around a bit, find the color, because all I see there is black, red, and that orangey color. But I know some of them are denoted as green. Green. At every turn, thwarted at every turn. This radio's hiding something from me it has no business hiding, which is how you select the bands. What is going on here? Well, this is really a very, very strange situation here, and maybe I'm just confused, but it sure looks like something weird has gone on here. So what I've done, since I can't seem to sort this out here in my shop, and with 100% certainty, I've asked the owner of the radio to photograph the cabinet, and hopefully on the cabinet it indicates how the band switch is supposed to work. That's what I'm down to. So I'm not going to do any more today. It's already been almost an hour anyway. And hopefully I'll find something out today, and then tomorrow with more certainty I can carry on. Because, I just don't believe what I'm finding.